This is another truss problem. Here we have a bigger truss now, not just 4 members, but now 11 members. And basically we're going to go through the same steps. We're going to do a free body diagram of the entire system, then of each node, of each joint, and then we're going to try and solve for all of our unknowns. So let's start with our free body diagrams. Remember that we don't have to, for the overall system, we don't really care about all these details here in the middle, as long as we know that there is an object and that the forces are acting somewhere. So I'm just going to do the outline, right, because we have nothing happening on the insides. There's a truss after all. There's no way that there's forces acting on the members directly. So we have an outline, outline that looks somewhat like this. Somewhat like so, and we have a bunch of forces acting. We have 20 kilonewtons out here. We have 10 kilonewton right there. We have another 10 kilonewton there, and then 5 kilonewton over here. That's our forces. And then of course we have some support reactions. You know, the 2 supports at A and B. At A it's our roller, so we get A. And at B we have a pin then, so that would be B, Y, and BX. Little coordinate system. 2D. No, all these distances are all 5 meters. But we can refer to the main picture for that later on. All right, then let's go through and do all of our little free body diagrams. So if we start at A, we have the support reaction. We have AB, AC, and AG. So our support reaction, of course, that support reaction has to point in the same direction here as it does in our overall free body diagram. And then our member forces will all pretend that they are, or not pretend, we'll assume that they're all in tension. So this would be, what do we have there? A, G, C, and B. F, A, G, F, A, C, F, A, B. And that was point A. Then point B will have the 2 support reactions, so B, Y, and BX. Then we have FAB going the other way, FAB. Then we'll have FBC going upward, and that's it. FBC, and that of course is point B. Point C sits right here. That's a busy one. So it has BC, AC, CG, CE, and CD all over the place. Let's make sure we have those correctly. So downward would, oops, that's black. Let's go blue. Downward would be FBC. And then we have FAC going in this direction. Then we have, what do we have here? We have FCG. A little hard to read. Let's give ourselves a little space there so we can actually read this later. FCG. Then we have FCE going upward. This is a busy one. FCE. And then what else do we have here? CD going at an angle. This is almost everybody right here. FC D. So definitely not the one that we're going to start out with. That was C. And then let's do D. Let's see, maybe we can squeeze the rest in here. That would be D is all the way up there. So it has E and C and the load. So it has, what was it, 20 kilonewton? And then it has FCD, FCD, and the other one, next one should be E. Yeah. FDE, FDE, and that's it. Then E goes to D, to C, to G, and to F, and has a load on the top. Oops, do this in black, consistency's sake. So you have the load on the top, which is 10. Then we have FDE, FDE, FCE going down. FCE, FEG going sideways, FEG, that was this one, and then FEF, also a busy one, FEF, and this was point E. Oop, we forgot to give. Say this was point D. Okay, EF has EF and FG and the load. So it has the load this way. That's 10 kilonewton. No. 10 kilonewton. Then to the right it has FEF, and down was FG. That would be FG, right? Yeah. And we have the load, and that's it. So that was point F. Right here, and then the last one is G, and then we're all the way around. G has a load, and then a whole bunch of other stuff. So we have the load of 5 kilonewton, and then we have FG and EG. Oops. FG is up here. EG is going up there. FEG, FCG to the right. FCG, and then that should be AG going down. All right. A lot of stuff going on. FAG. And that is, of course, point G. Alright, so now we have each of our joints. So we have all of our free body diagrams. So now we can do the overall support reactions. We can say B. What are we going to do? Well, I think the first one we can do is, so we only have one unknown in the x direction, so we can just do sum of forces in x, get that over with. Sum of forces in x equals 0. And we have bx positive. And then we have 10 and 15 negative. So minus 10 kilonewton minus 5 kilonewton. That means Bx is equal to 15 kilonewton. And let's say we had Bx to the right, it's positive, so it is going to the right. Let's just indicate that right there. All right, so for the other two, it's probably best to do moments. So maybe we'll do a moment around A, and then a moment around B. Sum of moments around A is equal to 0 is equal to, what do we get? We get 5 kilonewtons times 5 meters. You get 5 kilonewtons times 5 meters. So each of these blocks is 5 meters. Then this one also counterclockwise, so plus 10 kilonewton times 10 meters. We're doing it around A, so that means this one is going clockwise by 5 meters, so minus, what was the, wasn't, that was 10 kilonewton up there, 5 meters. 10 kilonewton times 5 meters, that one, and then also clockwise 20 kilonewton times 10 meters. And let's not forget the one that we're looking for. So By will be going clockwise, counterclockwise, 5 meters. So plus By times 5 meters. All right, that means By is equal to, so this was positive, so if you flip all the signs, so let's start down here, that'd be 200 kilonewton meters, switch the sign to positive, that would be plus 50 kilonewton meter, minus 100 kilonewton meters, minus 25 kilonewton meters, divided by 5 meters. So 250, 250, 150, 125 divided by 5. So that would be 125 kilonewton meters divided by 5 meters, 25 kilonewton. My By. By we said upward positive, so it is pointing upward. So that means now all that's left is A, so we can do a moment around B is equal to 0, and what do we get? So now we're at B, so we start with A. A is going clockwise, so minus A times 5 meters. This one is clockwise, counterclockwise and 5 meters, and the other one is counterclockwise and 10 meters. So we have plus 5 kilonewton times 5 meters plus 10 kilonewton times 10 meters. That was these two. Now this one goes straight through B, doesn't have a moment arm. And then we get, this one is now turning clockwise, so minus 20 times 5 meters. Minus 20 kilonewton times 5 meters. That means A is equal to, so this was negative, so all the signs stay the same. 25 kilonewton meters plus 100 kilonewton meters minus 100 kilonewton meters divided by 5 meters is 25 kilonewton meters divided by 5 meters, That means 5 kilonewton. It's positive, we define it upward as positive, so it points upward. Alright, so now we have our support reactions. That means we can go in and find all the other reactions. And I think what we're going to start doing here, because otherwise it gets confusing, I think we're going to start circling in yellow the stuff that I now know. Right, because I already know the other forces I already know, so now I need to find something where I only have two unknowns that would be easy to solve for. So look at B, for instance. That's going to be easy, right? I can do, if I do sum of forces in the y direction, I only have one unknown in there too. So let's say 1 and 2. That would mean that I know FAD and I know FBC. All right, so where is FAB is here as well, and FBC is there as well. Ooh, here's another easy one. This one's easy because there's only one component in the x direction, so that's going to be 0, and then that's going to be just 10 kilonewtons. So that's easy. So I will at that point then know them. So this one and this one, FFG is here and FEF is there. Now, where do I go next? I could go here. If I know FAB and A, then I only have two unknowns. I could do sum of forces in the x direction and get FAC. So this is now 1, 2, 1, 2, I have 1, 2, 1, 2 twice. This should be then 1, 2, this should be 3 and 4. So this is then 5 and 6. I know FAG, I know FAC. FAC is also here, and FAG is there. Now, so that was 5, 6. I can stay right down here at G. If I do sum of forces in the y direction, I can get FEG and then FCG. So I got these two, FEG, where's my E? And then FCG, where's C? FCG. Alright, so now, where else can I go? I can look at what's left. I can look at, for instance, I could look at E. There's only two unknowns here. So if I do sum of forces in the x direction, I could get this one. So let's put now 9. Oops, not in yellow. It's easy or hard to read. So this one would be 9 and 10. With that, we're almost done. I think there's only one left. So CE would be here and DE would be there. So now we can go almost anywhere, maybe right up here, and get our number 11. And with that, I know everything, right? FCD and FCD. All right, so that's going to be my approach. That's going to be my game plan. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. All right, so we start with point B. So point B be right there, and so we're saying sum of forces in the y direction. Fy equals 0 is equal to by FBC. By and FBC. By plus FBC. That means FBC is minus By. You found By earlier is 25, so it'll be minus 25 kilonewton. Minus 25 kilonewton. We assume that's in tension, so if it's negative, it's in compression. Then F, sum of forces in x direction is equal to 0. Where is my B? Right there. So it'll be minus FAB plus BX. Minus FAB plus BX, right? That's what I have. Minus FAD plus BX, yes. That means FAB is equal to BX. Where is BX? It's 15 kilonewtons. 50 kilonewton, and that means it's in tension. FAB. All right, that was my point B. That was 1, 2. Then in my strategy, go to point F. Point F. Number 3 was the vertical sum of forces in the y direction. Sum of forces in the y direction equal to 0, and that only has one single one. That's FFG, so that's equal to 0. FFG equal to 0. Sum of forces in the x direction equal to 0. And that is then minus 10 kilonewton and FEF. Minus 10 kilonewton plus FEF. FEF is equal to 10 kilonewton, and that is then in tension. Oops. All right, that was point F. Got those two. Where's my 5? My 5 is here at point A. And which one I'm going to do first? I'm going to have to look at the x direction first so that AG doesn't have an impact. So that was point A. Sum of forces in the x direction equals 0. Sum of forces in the x direction equal to 0. So I have FAB. So I have FAB. And I have FAC. Now it's at an angle, but these are all 45-degree angles, so that's good. It's easy. Where do we go? FAB. Oh, I forgot plus or minus. FAB. FAC is what I'm looking at. FAC is positive in the x direction. Okay. Plus 1 over square root of 2 FAC. Now just double checking here. FAB and FAC. All right. That means I'm probably not going to fit there. FAC, which is I'm looking for because FAB I already have, would be minus square root of 2 times FAB. That'd be minus square root of 2. FAB was 15. Kilonewton. Let's write this to look a little nicer. 15 square root of 2 kilonewton, which means it's in compression. FAC. And then sum of forces in the y direction is equal to 0. In point A. In the y direction would be A, FAG, and FAC. Everything positive. A plus FAG plus, now it's again at an angle, so square root of 2FAC. Make sure FAC is the one. Yeah. That means FAG is equal to minus A minus 1 over square root of 2FAC minus A, where do we have it? It's 5 kilonewton. Minus 5 kilonewton minus 1 over square root of 2 times FAC minus 15 square root of 2 kilonewton. Yep, that's going to be tight. So that would be minus 5 kilonewton minus and minus is plus. The square root cancels out, so it would be plus 15 kilonewton is equal to 10 kilonewton positive, so tension, FAG. Let's see, so this was 5, 6, 7, 8 point G, and we will want to, we're looking for EG, so we'll have to go Y direction first, right? Because that way CG doesn't have a component, the other two components we already know. So 7 point G is sum of forces the Y direction. Point G, sum of forces in the Y direction equal to 0. Let's see where we get that. Scroll, scroll, scroll. In the Y direction. So we have minus FAG and minus FFG, and plus FFG. Minus FAG plus FFG. Those we hopefully know. And then plus FEG. Plus 1 over the square root of 2 because it's an angle. I forgot which one. FEG. Now we have FEG twice. Oh, it's FG. FEG. That's the one that we're interested in. So FEG is gonna be equal to, bring those two over, so square root of 2 times FAG minus FFG equal to square root of 2 times FAG was 10 kilonewton. FFG, where is FFG? 0. That's always good. Probably should have marked that in a special way. That means we get 10 times square root of 2 kilonewton, which means positive tension. That's FEG. Then sum of forces in the x direction equal to 0. We're getting there. Sum of forces in the x direction is minus 5 and plus CG. Minus 5 kilonewton plus FCG. FCG, and then we have the one at the angle, which is we just calculated. It's positive in the x direction, so FEG plus FEG. Plus 1 over the square root of 2 FEG, right? Because it was at an angle. That means FCG is equal to, so it was positive, so I have to flip the signs, kilonewton minus 1 over square root of 2 FEG, 5 kilonewton minus 1 over the square root of 2 FEG, 10 over the 10 times square root of 2. So that's then 5, those cancel, minus 10 would be minus 5 kilonewton, so compression. FCG. All right, we are getting there. So that was number 7 and 8. So only 3 left. We get 9 and 10. So point E, and we'll want to do sum of forces in X. So point E, sum of forces in X equals 0. Where is point E? There. Minus CEF, minus, no, not CEF, minus FEF. Yes. Minus FEF, back up here, plus FDE. Lots of scrolling on this one, it's not high. FDE. And then minus FEG at an angle. Minus F, can't be DE, you already have DE. FEG. That means what we're looking for was FDE, right? That's the one that we're looking for. FDE, yes. FDE is then equal to, we need to flip both of those signs, FEF plus 1 over the square root of FEG. Let's see, where's FEF? FEF, 10 kilonewton. 10 kilonewton plus 1 over the square root of 2 of FEG. We have that still on the page here. 10 times square root of 2 kilonewton. That means 10 plus 10 is 20. And that will be tension. FDE. Then sum of forces in the y direction is equal to 0. Still at point E. That would be minus 10 minus CE. Minus 10 minus FCE, which we're looking for, and then we have one at an angle. We have FEG at an angle, so minus FEG. Minus 1 over the square root of 2 FEG. CE and GEG, right? CE and EG. All right. Looking for FCE, so that means FCE. That was negative, so all the signs stay the same. So it'll be minus 10 kilonewton minus 1 over square root of 2 FEG minus 10 kilonewton minus 1 over the square root of 2 FEG 10 times square root of 2. So that'd be 10 minus 10 would be minus 20. Minus 20 kilonewton, so compression. Okay, let's see. That was number 9 and 10, so the only one's left is 11. That's the one that's all the way up here. So to do that, doesn't really matter if we do in which direction we go. So maybe we'll do sum of forces in the x direction. So at the point C, oops. Point C, and sum of forces in the x direction is equal to 0. Now this was a busy one, so let's see. In the x direction we have minus FCG minus FCG. We have minus AC at an angle minus FAC there, and then FCD also at an angle but plus 1/2 FCD plus FCD. Right, so AC at an angle and CD at an angle. All right. That means solving for FCD, those both change their sign, and I have to multiply them by square root of 2, so it'll be square root of 2 times FCG plus the square root cancels out, so plus FAC. So that would be square root of 2 times FCG minus 5 kilonewton plus FAC, where is FAC? FAC minus 15 square root of 2. Minus 15 square root of 2 kilonewton. Oops, squeeze that in there. So that would be minus 20 square root of 2 kilonewton, so compression. With that, we have all of our unknowns, but we have 3 equations left, right? Remember that we use the overall system to get 3 of our unknowns, so we have 3 left. We have the y direction at G and then D, so let's use those as tests. Make sure that we're double check on our results. So sum of forces in the y direction equals 0. What do we get there? Y direction, we get 4 components. We get FCE and BC. FCE minus BCE. FCE minus BC. No, can't. BC. Yes, minus BC minus FAC minus 1 over the square root of FAC, and then plus the other one's at an angle 2. 1 over square root, that was AC, and then CD. FCD. So that will be equal to minus 20 kilonewton, I see up there. Minus FBC, where is FBC? Minus 25 kilonewton. Minus 1 over the square root of 2 FAC. FAG minus 15 square root of 2 minus 15 square root of 2 kilonewton plus 1/2 1 over square root of 2, I mean FCD was minus 20 square root of 2 kilonewton. Alright, I'm not sure I can handle it that easily, so that would be 20. That's the easy one. That is minus plus minus is plus, or times, not minus. That's another plus. Those cancel out, so it's 15 kilonewton Here the sign stays, but the square root of 2 cancels. Kilonewton. So minus 20 plus 25 would be 5, plus 20 minus 20 is 0. Very good. And then we have point D was left. What do we have at point D? Let's go in the x direction first. We have DE. So sum of forces in the x direction was minus FDE. Minus FDE, and then minus CD. Minus 1 over the square root of 2 FCD. Spending a lot of time scrolling here, huh? FDE, there, 20 kilonewton. So equal to minus 20 kilonewton. Minus 1 over square root of 2 FCD we just got was minus 20. Minus 20 square root of 2 kilonewton. That gives me minus 20 kilonewton. Minus and minus is plus. The 2, the square root of 2 cancels. That is also good. Now let's hope the last one is good too. Oops, we should do is equal to 0. Equal to 0. Fy at point D, that'd be minus 20 and minus FCD. Minus 20 kilonewton minus 1 over the square root of 2 FCD. Nothing changes with the 20. And then that's not going to fit. Let's just write this in the next line. Minus 20 kilonewton minus 1 over the square root of 2 FCD minus 20. Good, because that's the right number. All right, minus 20 kilonewton, the square root of 2 cancels, plus 20 kilonewton equal to 0. Woohoo! And the 3 tests all came up positive, so that gives us some level of confidence that we were correct. All right, so we have gone through, we did for this more complex truss here, we did all the free body diagram for the entire one. Then we did the free body diagram for each of the joints. Then we found what the forces are, the support reactions are. Based on those support reactions, that we knew the support reactions, we then went through and came up with a strategy so that we can get one unknown at a time. And so we went through all of these, and then we used the last 3 equations as a test, and the test came out that it was correct.